Welcome back, everybody. This time to Tech Talk number 33. Time flies. I'll be moderating the session today. Please note, as always, the session will be recorded and we'll be publishing it later on YouTube. So I think without further ado, the agenda is, as always, we'll be hearing our Tech Talk today. I'll then be giving some news and events, and then lastly, I'll be announcing the next Tech Talk for March. Without further ado, we'll jump straight in. Welcome to the Tech Talk dNation. We have Martin here today and Matus, and they'll be talking on lessons learned for running Yaook on internal network with bonded interfaces to double the bandwidth. So I'll give the stage over to you, Martin. I think you're the first to present, and I'll be giving you the rights.
Sure, thank you. I'm going to share my screen now.
Yeah, you can get started.
Okay, I'm going to share my screen. Share external. Oh my God, this is the new software for me. Can you help me, please? Where is the button for? Oh, here. I got it.
Do you have it?
Yeah, it's.
Got it.
It's a bit complicated.
Bear with me.
You're all good. No stress.
Good. Can you confirm you can see my screen now?
Yeah.
We can see it perfectly.
Perfect. So welcome to our Tech Talk. My name is Martin Pilka. I'm CEO of the company dNation, and today I'm going to tell you how we actually tackle the problem of double the bandwidth on the AI cluster we are building right now. A few words about my company. The D in dNation stands for development and DevOps. So we are both software engineers and DevOps engineers. What we are doing these days, we are building sovereign AI clouds from Europe for Europe. We are also one of the 7 founding members of ALASCA. Few words about my team who is going to present with me today. We have also additionally to announce Matus. We have also Victor because we need his knowledge. So as I said, my name is Martin. I'm CEO, and these days I'm also designing clouds as cloud architect. But I'm not taking the credit for the whole thing. It's always the teamwork. So we do some drafts, and it's always multiple iterations with multiple people. And now I pass the ball to Matus. Please go ahead and tell us, please, a few words about yourself.
Okay, the mic is on.
Oh yeah, we can hear you now.
Okay. So hello, I'm Matus, and I work for dNation as a DevOps engineer, and my responsibility is mainly deploying Yaook with Kubernetes clusters and Yaook.
Sure, thank you, Matus. And now, Victor, ball is and stage is yours. Please tell us a few words about yourself.
Okay, so hello, my name is Victor, and I'm also working at dNation as a DevOps engineer. And today I will be showing you a quick demo of an MLAG redundancy test using GNS3 network simulator.
Perfect. Thank you, guys. Let's go to the next slide. So why do we need fast network in the first place? So recently we have installed 3 private clusters, and all of them include AI GPU nodes. One of them is supposed to be and is going to be a high performance AI cluster. And there are special requirements. They would like to obviously have as much bandwidth as possible on network, at least 200 gigabytes per second. But on the other hand, in their budget, which is 1.2 million, they would like to spend most of that on GPUs themselves. So they didn't have the budget actually to do the InfiniBand, which would do easily 400 gigs. So we had to come up with some solution. Well, and we did. What we did actually and proposed was to double the bandwidth via quite standard these days setup when one node is connected to 2 switches, each of them having 100 gigabits. And if you configure it correctly, then you have double the bandwidth. If you have any better ideas, by the way, how to do that, please feel free. We are open to suggestions. We do have some capacity to change the design even now. It's not deployed yet, but we are very close. It's gonna be deployed next month. Yeah, so feel free to ask questions as we go. Just raise your voice or raise your hand. Good. So that's how we actually came to the point that the network needs to be as fast as possible. All of the free clusters share the same requirement. We need fast network. Why that? Well, recent applications, they were a heavy east-west traffic. That wasn't the case before that. It is case now. There is self-storage. The self-storage requires each of the nodes connected to have as fast as possible connection. There are usually SSD drives. Those are fast. However, the network is usually the bottleneck. Then there are live virtual machines migrations. Those do not work at all if you don't have fast enough network, because as probably most of you know, when you are migrating machine, there is also migrated RAM, memory, and if you do not have your network fast enough, then the machine is never going to be migrated, because the content of RAM changes faster than you are able to transfer it to a new node. So it's a real issue. And then obviously AI workload. We are running OpenPrime. OpenPrime is an AI, sovereign AI platform. Basically, you can imagine ChatGPT running in the private cloud with the ability to pre-process certain documents so the answers are more accurate. For that, you need vector database, and for that, you need fast access. Otherwise, training materials it's too time consuming to train such an AI. So those are our reasons why we need a fast network as fast as possible. Traditionally, there used to be free tier architecture. There used to be access switches. Here are on the very bottom layer. Can you guys see my mouse pointer as well? Or not really?
Yes.
Yes, we can see it.
Okay. So traditionally, there used to be access switches right here, then aggregation layer, that's the second one, again switches, and then the core of the network. Between the layers, there is a mesh. Now, this is fine. It does work. The difficulty is that it doesn't support very well the east-west traffic, because when a node in Reg 1 would like to communicate with node in Reg 2, it has to go all the way up. And that's one hop, second hop, third hop. And with each hop, obviously the latency increases. So what's the solution for that? Well, these days, mostly we deploy two-tier spine leaf architecture, when we basically have just 2 tiers instead of 3. So when the node from Reg 1 would like to communicate with a node in Reg 2, it doesn't have to go all the way up. What we do actually, we do the cross cabling. In this particular case, this is what we came with. And again, feel free to object. What we did, we would like to skip the spine switch. When Reg 1 would like to communicate with Reg 2, we would like as little hops as possible, which is cross cabling. It does come with compromises, and it's less flexible. It's suitable up to 4 racks. Otherwise, the cross cabling thing actually brings too much physical difficulty. However, then you have better latency, because you can communicate directly from one rack to the other. So this is what we came with. One of the issues we are hitting consistently with each cluster is that hardware is never delivered in time. This particular hardware was supposed to be there at 16th of December. We are at the end of the February and it's still not there. It is supposed to be there early March. So what do we do? Well, there are two options. We can wait, but then once it arrives, as it goes, usually you need to install it really fast, so it's better to be prepared. The other option is you could use what is called GNS-free network simulator. GNS stands for Graphical Network Simulator, and it allows you to prepare network configuration without real hardware. You can also easily test failure scenarios. And last but not least, you have portability. Portability in a sense that you can run the whole thing in one VM, quite powerful VM it has to be, and then you can export that VM, pass it to your colleague who can play or actually improve the configuration you are working on together. That's quite important because the setup itself is quite time consuming. This is how it looks like. This is the screenshot from GNS-free. Most of you probably know that, but if you don't, well, here on the left, it is the simulation of RAG1. We, just for the purpose of simulations, we have just one node there called Ubuntu 1. Same for RAG2. We have one node there called Ubuntu 2. Then these Sonic 1, 2, 3, 4, those are leaf switches, 2 per rack. And obviously they are connected with these cables. Now, what can you do with that? Obviously, before the hardware arrives, you can configure and prepare commands for those leaf switches. In this particular case, they are running Broadcom Sonic operating system. We also experimented with community Sonic. However, it didn't work out well enough. And now I pass the ball to Victor, who is going to share with the live demo when the machine from RAG1 is going to communicate via ping protocol in this particular case with the machine node in RAG2. So Victor, the stage is yours. I'm going to stop sharing now. Or can actually two of us share at the same time?
I don't actually think so, unfortunately.
All right, not a problem. I'm going to stop sharing.
Okay, can you see my screen?
Yeah.
Yes, we can.
Okay, so what are we looking at here is a simple, as Martin said, it's the same setup. It's simple MLAC setup consisting of 2 racks, and we are going to do communication from Ubuntu 1 to Ubuntu 2. So the whole point of this setup is to test whether the communication between the racks survives after link failures, which is exactly what we need the MLAC for. So first, as you can see, all the links between the racks are green, so they're running. And now I'm going to start pinging the other PC. So as you can see, the ping is going, and now I will manually stop some links. If we hit a link that that has ongoing traffic on it, we can see some slight delay, but the communications should still be going. So let me suspend this link. So there was no delay because there was no traffic on that link. Let me try stopping some other. Okay. This one. Okay, so you can see there is slight delay, but the communication is still going. The delay is around 3 seconds. Okay, and now the last link. Again, we hit a link with the traffic. There was slight delay, but the ping is still going. So this is like it. It's a little bit simple, but yeah, that's how this good communication between the racks works. So
All right.
that's the key takeaway, that MLOC gives us link level redundancy between the racks. And now I will hand the word to Martin back again.
All right. Thank you, Victor, for presentation. If you could stop sharing, and I'm going to share now. Yeah. So do we have any questions until now? Because as I see, we are going quite fast. We are doing one slide in less than 2 minutes. So hopefully it's not too fast. If there are any questions, feel free to ask, and there will be another option to ask questions at the end, obviously. Oh, it seems everything's clear. That's fine. So let's continue. I am sharing my screen now. Am I? Yes, I am. Good. So we were able to simulate our network, or actually core of the setup we are deploying in GNS3 simulator. That's quite useful. Now we would like to test that in practice on the real hardware and focus especially on the differences which are between the simulator and the real hardware, if there are any. So now I'm going to pass the ball to Matus, who is going to show you the live demo on real hardware. In this particular case, it's gonna be single switch demo. And we are going to, instead of ping, we are going to use iPerf. Why that? Well, GNS3 is suitable for configurations, but not performance. It doesn't make too much sense to test the performance because it's all emulated. That's why we used ping in that particular test. But now the situation is different. We are actually measuring whether or not the bandwidth has doubled. That's why we are using iPerf. By the way, the performance from top of my head of iPerf in GNS3 simulation is about 10 megabits. So we are like 10 times under the performance of the real hardware. Good. Matus, the stage is yours. Please go ahead and show us the single switch demo with iPerf on the real hardware.
All right. All right. Can you hear me and can you see the screen? Yeah. So basically what we have here is it's a real deployment of a Kubernetes. It's actually Kubernetes cluster running on bare metal, connected on a network which has just a single MikroTik switch, which is 25 gigabits per second. And now I'm going to use iPerf to test to measure the speed. So I'm going from one worker node to another, which is like similar to the real case, because worker nodes are running Ceph, which is which has one of the biggest requirements on the network. So as you can see, we hit 23 gigabits per second, which is almost 25. There is some overhead for TCP communication. Okay, so and now I'm going to switch to another of our clusters, which has two bonded switches. Is basically like the picture from Victor's slides, but just one of the racks. And now we can see that is 49.5 gigabits per second, which is double, actually more than double the speed. So it is working, but also I'm going to demonstrate this redundancy feature, which was done by Victor already, but I will demonstrate it on the real hardware. So I'm just now going to disable one of the physical links of one of the physical interfaces. And we can see when the speed is going down, and it's 24, which is the half of the speed. And now I'm going to bring it back up, and we will shortly see there is also the delay, but it's going up. The link is alive, but it's not jumping straight to 49 because the iPerf is actually averaging over more measurements. So now I'm going to stop iPerf so we don't okay, and now I think that's it from the live demo.
All right, thank you, Matus. And could you stop sharing the screen? Yeah, thank you. So I'm going to share again now. Good. So to summarize, before the live demo on real hardware of single switch, iPerf was giving us close to 25 gigabits. You might wonder why not 100 gigabits. As I said, this is not the same hardware we are going to install on that high performance AI cluster. So it's not delivered yet. So what we did, we used the hardware which is as close as possible to the one we are going to have, and that's only 25 gigs per port. So that's why you are seeing 25 and 50 and not 100 and 200. So single switch around 25, two switches, 50 gigabits. Then when there is a link failure, it still does operate, but at the reduced half speed, 25. And when there is a link recovery, in around few seconds, you get 50 again. So it does work. I'm quite happy about it because it's a live demo. You know how it goes with live demos. Now, we have a good foundation, network foundation for cluster which has better performance. Here is the comparison in graphical chart. So as expected, with two switches, we double the performance. However, our application is not iPerf. It's just obviously the measuring tool. We would like to see the real improvement in real life applications, for example, Ceph. So one of the ways how we test Ceph with each new cluster, we have this IOZone command. As you can see, it's specially crafted in a way that actually it runs only the read and write tests, because we would like to have something which is easy to compare between various clusters. And there is this -I switch, which is actually bypassing the buffer cache and goes directly to disk. This is not perfect. It requires that the operating system itself propagates and respects this feature to hard drives and all the layers below. However, there are significant differences between when this switch is and is not used. So it's much better approximation than without it. So this is how we are measuring, and we can see that actually the read performance did double, not so with write performance. We have to investigate that. It's quite possible that with write performance, we have bottlenecks in the Ceph itself, I mean Ceph configuration, or not. We don't know yet. We have to investigate. So what were the issues we hit during the configuration of real hardware? There are many. As anyone who is working in this area knows, the very common source of troubles is network card itself. And usually it's firmware, it's the kernel, and it's the interaction between the two. So the good rule of thumb is to use the new kernel and new firmware for the network card. That does help and solves a lot of issues. Then we noticed that MTU size also does matter. We set it up to 9,000 to maximize performance. When it comes to GNS3, what does and what does not work? As mentioned before, obviously, you can't expect performance for GNS3. It's not meant for such purpose. So performance-wise, it doesn't match the real hardware at all, which is expected. What is worse, not all hardware features are supported. This depends on the image of switch you are using. Sonic Broadcom is supported quite well. There are switches like MikroTik where the support for the features which we need, like MLAG, is not in that image at all. So you can't use it. Then there are higher memory requirements. Well, that's expected. When you are simulating multiple devices, each of them, like Sonic Broadcom, is taking around 8 gigabytes of memory. When you have 4 of them, that's 32. Then you have virtual machines or nodes in racks. You can count like 1 or 2 gigs per. Long story short, it's probably safe to have like 64 gigabytes of memory to run that. It's possible to run it locally in some reduced setup on a notebook. Our intention is to run it permanently in one of our cloud environments we are taking care of, where we are going to have around 128 gigabytes available for that. All right. And we hit more issues, and now I'm going to pass the ball to Matus because he was the one solving them. Matus, please.
Okay. So you can keep the screen because I'm going to use Martin's presentation.
Sure.
I'm not going to show anything now.
Sorry, you're gonna have to share it again, Martin. Sorry.
Oh, yeah.
I took it away again.
No problem. I'll do that. I know how to do that now. It's quite easy. Here we go.
Okay, I still cannot see it.
I'll change the slide maybe now.
Oh, it's there. So we hit quite a strange issue during the installation and configuration. We was configuring just 2 bonded switches, and we have set up everything correctly and even updated the firmware, but we were still hitting around, the capacity was supposed to be 50, as you have seen on my live demo, but it was around 30 was the maximum I was ever going to get from the setup. So, and the cause of this issue was not the network, not the switch, not the cable. It was the PCI Express slot, which the network adapter was connected in. So the problem was a BIOS setting called bifurcation, which just reduces it splits 1/16 time slots to 4 time slots, and it's often turned on by default. However, our network card, which was Broadcom, had only PCIe 3.0, which when I did some digging and calculations, and there is capacity of 32 gigabits per second, which is insufficient for our case. The solution was to disable the bifurcation in BIOS. However, there might also be a problem that it's not bifurcation, it's that the PCIe slot is just not enough. So it's with, if it's a 3.0, then you need at least PCIe times 8, or if you need 4 or a bigger version. So, to sum up, if everything is configured as it should, if there is the switch is okay, the cabling is okay, the drivers, firmwares, everything, make sure to check the hardware itself at BIOS, because that might be the case of you hitting a bottleneck. So next slide, please. So
Yes.
after we successfully deployed the cluster and we had 50 gigs, it was time to install Yaook, and we decided to go with Cilium as a CNI. And we hit an issue with our provider network, and we were unable to, incoming traffic was not routed to OpenStack instances. And this was because the provider network ran on a separate VLAN, and Cilium made some extra routing rules, and it broke the routing between the main interface and the VLAN interface. Like the main interface and the one which is usually marked by .4000 or whatever the VLAN you're supposed to use. And this was very hard to debug, because the rules, it wasn't really clear that there are some additional Cilium rules. Also, there was a whole neutron on top of it, which complicated stuff really stuff, and we learned not only things about the Cilium and routing and networking, but also about neutron, because we thought that neutron is configured wrong. So and our solution was to use Calico, because Yaook, it's recommending it. We used it on our previous installations of Yaook, and it worked fine. But this was a very headache-inducing issue, but we learned new things about not only about Cilium and VLANs, but also about OpenStack, neutron, and so on. So next slide.
Okay, I will add regarding our motivation for Cilium. We wanted to have a cluster which is as close to possible to one of our partners, and they are using Cilium. So that's why we decided to do so. However, there's a difference between our case and their case. They do not have the incoming traffic tagged with VLAN, which we do. So they didn't hit this issue. So that was our motivation to change the Calico default. All right, next slide. Lessons learned. Well, with the next clusters, we are going to remember things like, before we start any installation, we are going to manually check each network card and its firmware version. It's quite a lot of work, but we have to do that. If we don't, we might hit strange issues. As we will do that, we will also go through physical machines and check whether the network cards are in the right slots. This was supposed to be so also for the cluster we were installing before, but somebody, we don't know actually who was it, did a mistake. So we made an assumption that the network cards are in the right slots. That wasn't the case. So that's the first thing we are going to check before we start the installation. Then obviously there are differences between GNS free simulate and the real hardware, but those are easy to spot, so it's not really a big issue. Advanced features like MLAG are not supported, and obviously performance Cilium doesn't work out of the box with VLANs. Well, good to know. If you don't use that, you don't have that problem. And thank you for your time. Now it's a good time to ask questions if you have any. And if you don't, then I have one. How do you guys, if you have some operators here, how do you guys do that? How do you achieve the best possible network latencies in your clusters? So we would like to compare our approach and your approach. Thank you, and please go ahead with your questions. Okay, we don't have many questions. It seems everything was clear.
Well, first off, Martin, thank you guys so much for your presentation. It was very interesting. And we're just going to give it a few more minutes, and maybe somebody has a question. But if not, we can always start with your question. If you guys have an answer to Martin's question, that would also be great.
Yeah. You know, we discussed this with multiple companies and the relevant people, and I really would like to have the confirmation that this is the best we could do. Oh, we have a question from Friedrich.
Yeah, hi. Thanks for your talk. I can't answer your question, unfortunately, but you mentioned in passing that you looked at the Sonic community build, but you weren't happy with it, or it wasn't working. Could you elaborate on that?
Oh, yeah. Okay. Let me remember what was the exact problem we had there. From top of my head, the build did not support the feature like MLAG. I might be wrong here. Victor, could you confirm or reject this theory? Because the honest answer is I don't know. Why did we not use the community Sonic?
Yes, I think so. When I downloaded it, didn't have the MLAG feature.
Okay, so I was right. Does it have MLAG features these days, or did we do something wrong? Maybe we found the wrong image. We have another question from Ramkan. Please go ahead.
It's not a question, I'm sorry. It's just the clarification for the MLAG for Sonic community. The thing is, Sonic community does support MLAG, but you have to download an image. By default, it's off. The flag is off for ICCPD, and you have to get an image with ICCPD enabled.
Okay, so there is community built image, which now has the MLAG. If you would be so nice, please, could you, if it's easy for you to do, pass the link to the image or just your email address, and we will follow you up, because this is interesting for us.
Yes, sure, I can do that. Actually, I am not sure if we have a pre-built image. I mean, I do have a pre-built image because I built it from the source, but there is no common repository yet.
Okay, got it. Now it comes to my mind, how did we actually end up with Broadcom Sonic? The MLAG feature wasn't in the pre-built image, and we had to build it ourselves. That wasn't a trivial process. So we talked to a few partner companies, and they basically told us, don't do that unless you have 2-3 days of your time to compile and build the image. So we didn't. We did go with Broadcom. Can you estimate how hard it is actually to build the image?
Okay, so the initial build process, when I completed the first build successfully, it took around a week. It is it is difficult, of course, but like since then there has been updates in the master branch, and there is a documentation as well for successfully building it in one go. and now
Got
it
it.
should be possible.
Got
Like
it. So
in 1 or 2 days max.
So it improved recently. And what was the main issue? I mean, when you're building the image, why does it take 1 week? Is it the compilation itself, or is it a lot of errors, or what's the main issue?
Yes, so there are multiple things. So for the first while, it is not mentioned anywhere that you have to enable that that flag for MLAG or other supports. So technically, you just have to figure it out yourself. And second, there are errors. There were a lot of errors, like for some permission issues and then some version mismatches and like firmware mismatches. So those have to be also configured on your own, but then those things have now been fixed. And the build process itself takes a long time because it builds like a ton of Docker containers and like Docker images, sorry, not containers, Docker images. And all those image build processes takes a long time.
Got it. Got it. So it sounds like we did a good decision to not use it at the time, but that decision has to be revisited now because somebody improved the process. As we talk, actually, I checked and I submitted myself to the mailing list. Somebody pointed to in the chat about Sonic community build. So we're gonna follow that. Thank you for that suggestion.
Yes, about that, in that Sonic community build as well, you will find the document, which is there is a GitLab repository which will be shared, I think, later by Helena.
Sure.
Yeah, and there you will file the documentation to build Sonic community properly.
All right. Do we have somebody on the call who is using the community built images or self-built images in production?
I am using the community built images, but not exactly in production. I have a lab set up with 2 Dell switches and Ubuntu server. So I'm using it to test the features and, make those documentations.
Got it. Got it. Thanks. All right. Any more questions, please? All right. It seems we don't have any more questions. So thank you very much for your attention. Now I will pass the ball to Helena so we can call it a day and have a weekend. Yeah.
Thank you so much. As I said, thanks for your presentation, Martin. Can you, no, hang on, you cannot see my screen yet. There you are. Okay. Thanks so much for that presentation. I'm going to be moving on to community news, starting with hackathons that we had throughout the last 2 weeks. There was actually 2. There was one held by SES, and then an ALASCA hackathon together with a company in Germany that we had this week. And Friedrich has already come back to the screen, and I'd love you to give us a little bit of a recap on those.
Yes, thanks. So the ALASCA Focus team was present at both events, the SES Hackathon in Fürth. We were invited by Scale Up and worked on various topics surrounding Kubernetes as a service standardization. And as you can see, also had a nice tour through their data center. That was very nice. We were much more involved, of course, in kind of our own hackathon. This week in Hamburg, we were invited by Dataport, a member of the STS forum, like dNation as well. Shout out there. And there we worked on bringing the STS standards and Yaook, our OpenStack distribution, closer together. So we started working on automating the STS compliance check in Yaook. A group looked at syncing OpenStack resources and representing them in Kubernetes itself to bring these worlds closer together. And there was also a session on sharing community knowledge on running Tempest tests, so end-to-end tests, which are mandated by the SCS standards to be passed, with the aim to improve defaults in Yaook and just make life easier for the operators. Yeah, that was the last 2 weeks.
Matthias, go ahead. You can just speak up. Thanks, Friedrich.
Yeah, I'm sorry. I actually meant to give a reaction, and then I hit the wrong button. But I'm going to take this opportunity to say thank you to everyone who was involved, and especially Friedrich, because those were really great events. And yeah, no, I'm quite fatigued from all the traveling, but the events were really great. So thank you, everyone.
Nice. Thanks, Matthias. Yeah, and I'm just going to hop on top of that and give one more thank you to Dataport for also sponsoring or partially sponsoring the hackathon this week. So thank you for that. All right, moving on to upcoming events. The spring is always a busy time event-wise. There'll be the FOSS Backstage, which will be March 16th and 17th in Berlin, and we as ALASCA actually are giving a talk. We turned in a contribution and it was accepted. So Daniel will be giving a talk called Saxony in Action, Supporting a Lasting FOSS Foundation. And if you are there at FOSS Backstage, we'd love to see you. We'll be around somewhere, so come find us and let's have a chat. And then also in March, there's the Chemnitzer Linux Days. At the end of March, and we are heavily representing ALASCA there, which is really good news. We did get accepted for a talk, a workshop, and a booth. This is also the first very official time that ALASCA does have a booth at an event, so that's great news. And the talk is called Shift Your Focus, Digital Sovereignty with ALASCA. And then there's the workshop, which is called, it's about Yaook, and it's about US hyperscaler free Kubernetes on OpenStack. Yeah, so again, if you are there, if you're joining, we'd love to see you. You can find us at our booth that time. And of course, we'll be excited if you guys would join our talk and our workshop. If you do make it to the events, you can find more info on both of the events down in the through the link. Right. Oops, that's too fast. Also coming up is the Cloud Fest on March 23rd through 26th at Europa Park. Unfortunately, we won't be having a booth there, but there'll be a community lunch. Thank you to Linda from Cloud and Heat. She's organizing that community lunch. It'll be on Tuesday. Specific times will be communicated through mail and LinkedIn, and it's just supposed, there's no agenda or anything. It's just supposed to be a nice place to catch up, get together for everybody, for the community that is joining CloudFest. If you guys are in the mood, you'll be meeting at the gate, but as I said, info will follow on that. Also, there's the StackConf coming up in April, and one of our members called Cloud and Heat actually has a promo code for tickets. So if you have been thinking about going and you haven't decided, you can still get your ticket for 15% off using that promo code that you can see there. And other than that, there's the SCS Summit. I think we already announced that last month as well. It's at the end of May, and call for contribution is open now. So turn in your contributions for that event too. And then we have a new associate member, which is great news. It's the Open Source Business Alliance. And we support a lot of things as ALASCA that foundation does. So we're excited to be not working together, but we're excited to have them as an associate member and their foundation as an associate member. Oh, that's one too many again. The summit is always present as a topic. Next week, we'll be starting with call for contributions. We'll also be opening the registration, so big things are coming. The call for contributions will be open until May 31st. So turn in your contributions. We're excited to see what's coming in. We'll be having the option for short talks again, longer talks, workshops also. We're also always excited for workshops because we've noticed that hands-on experience always is appreciated very well by the community. So we're excited to see all of your contributions. We're excited to see registrations come in. And just a little hint on the side, we've switched locations this time just because the event is growing. And the event will be held in a hotel this time because they have great location spaces, event spaces. But as I said, it's also a hotel, and there's around 150 rooms that are currently blocked by ALASCA, so that you can book them. For all people that are coming from outside of Dresden, it's still time. The event is in November, you guys know this, but I just wanted to let you guys know now. The rooms will be going back onto the website or to the market on August 2nd. So until then, you can book rooms there. As I said, info on that will be going around, but you've heard it. You already know.
Helena, what is the deadline for submitting proposal for ALASCA Summit, please?
For a talk and workshop?
Yes.
That'll be end of May 31st.
Oh, that's quite early. So it's half a year before the event itself. All right.
We'll probably open it up longer, but you just heard it here.
Fair enough. Thank you.
Right. All right. Okay. That's everything on the ALASCA Summit. And that's the part where you can also, of course, add events or news from the community if you have any. Which doesn't seem to be the case. So thank you guys so much for joining. Thanks. Oh, go ahead. Sorry, I was too fast.
Yeah, we are going to have talk mentioning ALASCA on Open Cloud Sovereign Day, which is organized by CCNF. So it's quite a big conference, and we are going to prominently mention ALASCA in our presentations because the clusters we are building are built on top of Yaook technology and also Arco. So yeah, we are going to get some visibility there. Unfortunately, it's the same dates as the other event you mentioned today. It's from 22nd of March until 25th of March. So there is a full match. So we're gonna miss that one, but we will do what we can in Amsterdam.
Great news. Thanks so much for that. If you do need any type of marketing materials or whatever, you can
yeah,
let me know.
We'll be in touch. We'll be in touch. Yes.
Yes, we'll be in touch. All right. I think that's everything. If you guys have a topic that you want to submit for the Tech Talk, you can always go ahead. We're always looking for topics and speakers. And I think, oh my God, I almost forgot. Whoops. The next Tech Talk coming up. Next time in March, we'll be having Mark Schöchlin from Uhuru, and he'll be talking about standardized observability at scale with UMON. And we're very excited for that. We can't wait. And with that, I'm going to be ending today's session, and I wish you all a very sunny weekend. Bye.
Thank you. Have a nice weekend. Bye-bye.
Thank you.
Bye.
Bye-bye.